Welcome to Textbook Engineering Problem, where we explore complex engineering problems and discuss different methods for solving them. In this video, I'll be breaking down a problem and discussing different ways to tackle it. However, keep in mind that there is no one correct path for some of these solutions, and I encourage you to share your own insights and thoughts in the comments. Together, we can learn and improve our problem-solving skills. So, sit back, grab a notebook, and let's dive into today's problem. Today we're working out of Elementary Principles of Chemical Processes, 3rd edition, and we're doing problem number 4.12. 1,000 kilograms per hour of a mixture containing equal parts by mass of methanol and water is distilled. Product streams leave the top and the bottom of the distillation column. The flow rate of the bottom stream is measured and found to be 673 kilograms per hour, and the overhead stream is analyzed and found to contain 96% weight percent methanol. Part A, draw and label a flowchart of the process and do a degree of freedom analysis. Okay, so we've got our process here set up. This is our distillation column. We've got an input stream. They said it was 1,000 kilograms per hour, and it's 50 by 50 weight percent. Then we've got two outlet streams, one there and one there. They gave us the composition of this stream, and they did not give us the composition of this stream, but they did give us the flow rate of this stream. They did not give us the flow rate of this stream. Okay, so I've highlighted all of the unknowns in yellow. I put a blue marker here because we do have the process specification that there's only two components in this stream, and so this, all we need to know is one of them, and then the other one will be 1 minus whatever that composition is, that weight percent, or weight fraction. Okay, so we've got 3 unknowns, we have 2 material balances we can do, and then we have that process specification. Okay, here are our 3 independent equations here. And then I labeled our unknowns 1, 2, and 3 there. So we have 3 equations and 3 unknowns. This is our material balance on the methanol, material balance on the water, our process specification equation. 3 equations, 3 unknowns. That's our set of rules with independent equations. Since we have this problem set, we can solve these system of equations. And then, that's the answer for that. So that answers how to calculate all the mass fractions and flow rates and things like that of the product streams. Okay, so for part C, it says, suppose the bottom product stream is analyzed and the mole fraction of methanol is found to be significantly higher than the value calculated in part B. List as many possible reasons for the discrepancy as you can think of. Include in your list possible violations of assumptions made in part B. Okay, so here's my list. There's probably several other things that could go wrong in a process like this, but here's a few things that I'm aware of that I think are some of the more common things that can go wrong with a distillation column. If there's a significant amount of methanol in the bottom stream, that means the methanol is not making it to the top stream, and that could be because the top stream is plugged. The distillation trays could be flooded, so what happens here is that your flow rate going into the distillation column is so high that the bubbles, instead of separating, the bubbles are carrying liquid with them because they're moving so quickly. They're like bringing liquid with them on their way up, and it can flood the column is what it's called. So that liquid that should be going out the bottom, there's so much upward momentum from the bubbles that it's carrying that liquid that would, if you let it sit long enough, separate from the bubbles, but it doesn't get a chance to separate because it's moving so quickly. There could be just not enough heat going into the distillation column to actually cause this full separation. So maybe you do have a certain vapor that's occurring, but the heat that's coming off, the temperature isn't high enough to actually get a good separation. there could be like a crack or a leak in the vessel, and so maybe you are separating, but then the fluids are able to mix back together somehow through either like a crack or a leak or something like that, where there's flow where there normally shouldn't be any flow. And that could be inside the vessel, or it could be outside the vessel or around the vessel or something like that. Maybe you have a broken pump, so you don't have the flow rate going into the vessel that you thought you did, or you have recirculation going back to the flow going back into the vessel that shouldn't be. Maybe a valve is stuck open or something like that. The last one is the feed rate's too high. Well, that kind of goes into having a flooded column as well, but maybe your flow meter on your feed rate is too high, and your flow meter on your feed is not working right, and so you think you're at a flow rate when you're actually not, and your flow rate is a lot higher than it should be. Then that would also cause this flooding problem, kind of tied together with that. So anyway, those are a few things that can go wrong with the distillation column. Well, that is it for problem number 4.12. Thank you for watching, and I hope you found this video helpful in your problem-solving journey. Remember, there are other routes you can take to arrive at the same correct answer, and I encourage you to comment with any additional insights or questions you may have. Also, if you have any specific engineering problems you would like me to cover, please let me know in the comments. Your feedback is valuable, and I look forward to continuing the conversation with you. Don't forget to like and subscribe for more engineering problem-solving videos.